Patty Simpson with Simpson Math. In this video, we're going to learn about sampling error. Sampling error is just the tendency for a statistic to not exactly match a parameter. So let's remember first, what is a statistic? So when I go out into my population and I gather data from a sample, and I've gathered all this data, and I take that data and I narrow it down to one number to represent the data. Something like an average, or maybe a proportion, or a percent. Once I've narrowed all my data down to one number and my data came from a sample, we call that a statistic. Whereas if I've collected data from my entire population and I narrow it down to that one number, that average or that percent, we call that a parameter. Now, most of the time we can't get a parameter. It's really hard to do to get data from the entire population. So most of the time we are just getting a sample or a statistic when we have that one number. So because of that, our sample that we've taken may not be exactly like the population. In fact, it's, that's hard to get something that's exact. So to find this sampling error, what we do is we take our statistic, the one number from our sample, and we would subtract the population parameter to get our error. So here's an example of that. Let's find the error. If we find a statistic is 43%, but in actuality, the one number to represent the data should have been 45%. Or that parameter was 45%. By the way, this error may happen not from any, not that anybody's making a mistake or that they're doing anything devious. It just happens that your sample sometimes is not exactly the same as the population. So to find that, what we do is we take our statistic, that 43%, and we subtract the parameter of 45%. Now we saw earlier that when we have integers and their signs are different, we really just subtract the two numbers. So 45 minus 43 gives me 2. And then I keep the sign of the larger number, in this case 45. So I started in positive land, I walked towards negative land, and I actually made it to negative land, because 45 was bigger. So my statistic is 2% less than my parameter. And it's really important that we put our statistic first and then the parameter, so that we can see this -2 tells me that my statistic was too low. If it had been a +2, then I would know that my statistic was too high. But in this case, it's a -2 to let me know that my statistic's a little bit lower than the actual population. So there's my sampling error. Here's another example. Researchers want to determine the average height of men in the United States. The researchers measure the height of 1,000 men and find an average is 69 inches. So they have 1,000 different heights written down, but they've reduced those 1,000 numbers down to just 69 inches. One number, which is called since it's from a sample, it's called a statistic. If the actual average of the population is 68.8 inches, find the sampling error. This 68.8 inches is one number to represent the entire population. So this is the parameter. So in this case, here is my statistic, and this is my parameter. And I want to find the sampling error. All I do to find that sampling error is take my statistic and subtract my parameter. Their signs are different, so I really am going to subtract the two. Remember, when you subtract, you've got 69 and here's 68.8, line up your decimals, put a 0 there, and then just subtract. I need 2 more tenths to get to that. And then maybe you borrowed from here to get there, so that is just equal to 2/10. In this case, the 69 is larger than the 68.8 and it's positive, so my answer is positive. My statistic was larger than the parameter, so my sampling error is 0.2. So that's how we can use adding and subtracting integers to help us define that sampling error. Math Made Simple at Simpson Math. Thanks for watching.